Okay. So, uh, let's remind us about the tech talk tonight. All right, so the first tech talk is tonight from 6 to 8 p.m. This is in the Plaster Building, main floor, right outside the makerspace. The speaker tonight is a guy named Eric Johnson from WDC, or from Aurora. WDC, they're an AI data science business logic company. I think he's a really, I think he'll be a really good speaker. Very interesting, very engaging. So that is 6 to 8 p.m. tonight. There's an assignment associated with this that is due by Sunday midnight. So if you go to the talk and you listen to it, the assignment is to write a short summary of kind of what you got out of the talk and how you're going to apply it to your career. If you're not able to go to it, there's a 4-page paper that you have to write based on the speaker or the company. You can find his LinkedIn profile and use the website for the company. I encourage you to go to it. We put the dates up and stuff at the very beginning of the semester. So you've had whatever, a month or something like that to, rearrange work schedules and stuff. Yeah.
Is there going to be like a sign-up sheet or something when we get there? Or do we just kind of go?
Well, we'll have a video of it. So if I suspect you're lying, then I'll. But yeah, there's not going to be like an official thing you have to sign. If you absolutely 100%, I posted this on General this morning, are able to, you're available at the time of the event, but you just can't be physically at the event. There is a live stream of the event that you can private message me and tell me why you can't be at the event live, and I'll give you the link. This is not something you should use as a convenience. Keep in mind that when we invite speakers in, they don't expect to speak to an empty room. All right, so you sitting in your dorm room listening to it live while this guy's speaking to a bunch of chairs would not be appropriate. All right, so that's tonight, 6 to 8 p.m. Yeah.
If we're only able to make it to the two parties.
Would it be the first part of it? No. The first part of it would be more ideal because I schedule it for 6 to 8 p.m., but the speaker, rarely do they go till 8 p.m. Usually it's like 6 to 7 or 7:20, something like that. So you could expect to probably leave before 8 p.m., but showing up at 7, you might miss it, is what I'm is what I'm getting at. All right, any other questions? I know a couple people had messaged me about having trouble asking off work at this late date. That's why I announced it and put it up on Blackboard day 1 of class. So you already had the dates reserved and things like that. So if you didn't make that a priority, that's, I guess, on you. Okay, so in any case, let's talk about the homework first, and then the stuff you'll need for the next assignment. And then we'll go back and talk about our shortcuts for octal and hexadecimal. So today's homework was to write a function for the area of a circle. Okay, so area of a circle. So what we want to start thinking about here is, remember the name of the book we're using is what is it, Automate the Boring Stuff or something like that. So we want to start thinking about how we can leverage this weapon that we have, computer programming, to start automating certain things. In the past, we've had students who are in math classes, write computer functions to, programming functions to solve their problems from their calculus class or their algebra class. And what's actually good about that is by writing the code to do something that you're learning how to do in class, you're actually teaching yourself what you're supposed to be learning from class, because you're writing the recipe for solving that problem in code. All right. So what is the formula for area of a circle? pi r squared. So pi times r squared, right? Where r is the radius, half the diameter. All right, so we can ask the user to pass in the diameter. We could ask them pass in the radius, either one of those. But in order to make this work, somebody needs to provide us with the information. The input that we're going to require is either the radius or a way to get the radius, right? All right. Otherwise, pi is a constant and 2 is a constant. You know, it's a literal. So we have all the rest of the information that we need. If you provide us with the value for r, we can give you the area of a circle. Correct? All right, so that's what we're capturing here. Just so I don't forget. And remind me each class, I try to do this, but I'll put like the snippet of code that we wrote during class up on Blackboard. Or I'm sorry, up on, I have to do it from, give me a moment. I think I need to copy that with that. So this is code from class 217. So if you always remind me at the end of class to put the code up, I'll get the code up on Slack, so you don't necessarily have to retype it from a video. It's not my intent to hide it from you, just you have to remind me because sometimes I'm answering questions right at the end of class and stuff. All right, so that's in the 200 channel on Slack. And again, another reminder is make sure you're checking the general channel on Slack daily. We make announcements on there. I talked about the Tech Talk and internships get announced on there, special events, all sorts of stuff like that. So Slack should be something you're checking often. All right, so we want to define a function. Maybe we call this area of circle. And we've decided that we need to take in the radius as a parameter. That's the input we need to make this work. Okay, you can call it r, you can call it radius, you can call it d for diameter, and then divide it by 2. Because the radius is half the diameter, right? You can choose how you want to do it, but we'll go ahead and take the radius in here. Area of the circle is this, so we're going to say answer is equal to pi 3.14 times, and then it is the radius squared, right? And if you don't like saying radius squared like that, remember we talked about last week sometime that is not radius squared, but that would give us a numeric answer that does the exclusive OR which is a bitwise exclusive OR of whatever the radius is and 2. So you don't want to write it that way. You can either use the power symbol like that, or you can just say what it means. Radius times radius. So radius squared is radius times radius, right? But I'm going to go ahead and we're going to use it to the power, and then we're going to return the answer. You could have also just returned this value right here directly. But I went ahead and just stored it in a variable and then returned what it was. You didn't have to call this guy answer. You could have named that variable whatever you wanted. But if you name it LOL, when you return it, you're going to return LOL. All right. So at this point, that's an untapped resource. If I want to test this a couple times, I can say area of circle, and I can pass it, I don't know, 5. Similarly, I can say area of circle. I know I have it misspelled up here. So I'm calling I wrote my function once. This guy takes in a parameter. I've written it generically in terms of whatever that parameter is. I'm now calling it 2 different times. First time passing 5 in for radius. The second time passing 13 in for radius. These guys will calculate a result, return that result. This will boil down to that result. What am I doing with it? I'm printing it. So there is my area of those 2 circles. That makes sense? All right, so that was the homework for today. All right. The next thing we want to start thinking about, so I'm going to give you the coding stuff first, and then we'll finish up class, presuming there's time, with our conversion stuff, because I want to make sure we keep us moving forward with the programming stuff, is we want to start thinking about lists. And at this point, you probably have at least read about lists in the book. You should keep pushing forward in the book. All the stuff that the homework is over is covered in the book, but anything that you'll need for the homework assignments, I'll also cover in class. Okay, so that isn't to say don't read the book. It's just to say that I'm not going to rely on you reading the book to do the homework. You should get it from both places. Okay? So let me go here. All right, first of all, any questions about the homework that was due today, the area of the circle function? Okay, so do you kind of see how you could extrapolate that if you're in a algebra or a calculus class or something like that, and you're learning a certain skill right now? You can decide, oh, I'm going to help teach myself the skill I'm learning in class by going and writing a function that solves that problem too. And that hopefully is going to reinforce the steps required to do the math when you have to take your math test, because now you've written it in unambiguous instructions, unambiguous steps to solve the problem. So this is a skill, if nothing else, than study for your math stuff. Okay, or really any class, if you're in economics class or something like that, anything that requires some calculation type stuff. All right, so we want to start talking about lists. So lists are collections of items in most languages, but we're going to deal with this in Python. Python has multiple different collections. I'm just going to give us a precursor to this. Call this collections in Python. So we have strings. These are collections of characters. We have a list, which is a collection of anything that is a type in Python. So if a string is only characters, a collection can be characters, but it could be integers, it could be strings, it can be objects, which you haven't written yet, but a list is a collection of things. Okay? And then the last thing is something called a dictionary, which is a collection of name-value pairs. And if you've had some other programming languages, and again, I'll re-explain this stuff when we get to these specific things. I just want to kind of give you a single slide that gives you the comparisons of our collections. This is like structs in C. You could also say this is like an object without functions. If those don't mean anything to you right now, that's fine. All right, because again, I'll re-explain all this stuff, and when we cover some of the things, we will have other knowledge at our disposal. All right, So strings are just collections of characters, which are pretty common. We'll use those often. Lists, collection of anything. Dictionaries are a bunch of name value pairs, so allows us to hold kind of knowledge. Like if I want to hold a person's first name, last name, and age, I can have a single dictionary that says first name is Mike, last name is Littman, age is 18, something like that. All right. So let's talk about lists specifically. Actually, before I introduce lists, let's introduce strings. The book's definitely talked about those, but so if I have S is equal to hello, for example. So I have a string that contains hello. Hello is a collection of characters. So the length of S would boil down to 5. If I print S, it would print out hello. But now I can also loop through a collection like a string. So let's look at these things in, so we'll start with strings, then we'll see how lists are basically identical. I'll leave that up there. Well, actually here, let's just do this. So now you have that code. So I'll gut this. So I'm going to say S is equal to hello. If I go ahead and print the length of S, that'll give me a 5. If I print out S itself, that'll give me hello. So there's my 5 and my hello. So now we have this new function here called leng, which gives you the length of a collection. So length returns the number of elements in a collection. So in this case, I created a collection of characters, which is a string, and I printed out the length of that string. In this case, it was hello. If I say S2 is elephant, and I printed out the length of S2, this would give me an 8. So there's the length of hello is 5, the length of elephant is 8. All right, questions about any of that? So we have another tool. This is kind of like int and str that we've had before for concatenation and converting numbers into strings and strings into numbers, those guys. All right, so we have a third tool now that allows us to do some stuff. So now if we want to iterate over a string, actually I'll leave that stuff in there. If I want to iterate over a string, I can say for I in range 0 to length of S, then I can print out S at bucket I. And it gives me the individual characters from this guy. All right, so let's talk about what that means. Collection representation. Collections, and I'm going to say with the exception of dictionaries. Not necessarily because this is an untrue statement, but we wouldn't use dictionaries by indexing through them. Okay, so we'll just say collections, with the exception of dictionaries, are indexed starting at position 0 and ending at the length -1. So for instance, for the string hello, legal positions are 0 to 4. Bucket 0 is the H, bucket 1 is the E, 2 is the L, 3 is the L, 4 is the O. 5 would be an error. It's off the end of the string. All right, so legal positions are the starting at bucket 0 up to the length -1. We happen to know that our range function here goes from this value inclusive up to but not including this value. So if the length of S is 5, this is only going to go to 4. It will go to the length -1 because of how range works. Range says generate all the values between this guy and this guy -1. Make sense? So our knowledge of the range function tells us that I don't say -1 here, because if I say -1 here, I'll skip the O. And then we just have hell. Christian worldview, point. All right. So that makes sense how range works. We've seen it work by just looping through something some number of times, but now we're seeing that we can use it to index elements of a string. All right, or elements of any collection, including lists. There's also an alternate way we can work with this. We could say, I'm going to name my variable C. Now keep in mind that this does not have to be named I. I can, again, call this guy LOL if I want. Just when I go and use it inside of here, I have to name the variable whatever variable I defined it as. So if I want LOL to be every value between 0 and length -1, and then I'm going to use that value to index my string, I need to say LOL here. There was nothing magical about that variable I, other than the fact that mostly it's a throwaway variable. We're just using it to go through every element of something. Or I'm using it as a quick storage thing for a number. So in programming, you typically would never have more than 3 loops together. So a loop inside of a loop inside of a loop. So your go-to moves for those indexes are usually I, J, and K. For no other reason than just naming convention, historical naming convention. You can name your counters whatever you want. If you want to name it LOL, that's fine. All right. But as a general rule, we'll throw this out here. General rule about variables. Name your variables something meaningful so you know what they hold. Variables like I, J, K for loops are okay because they are, I'm calling them throwaway variables that only serve a counting purpose for a short period of time. But as you might imagine, as the amount of code that's inside of our for loop gets larger, it might be helpful to have a more meaningful. So, we could call this guy pause in string, for example. Now we have a fairly meaningful variable name for what we're actually trying to do. We're walking through our string S, and we're indexing a particular position in that string. So now we have a variable name that's pretty meaningful, but as you might imagine, having a variable name that long when all I'm doing is giving myself an index probably is not required. So choose your poison, I suppose. All right, so now an alternative to this is we could say for, and I'm going to say a character, HR, in S. And we see we get the same result. So I'm using this in keyword to now, instead of pos in string being each of the values in this range, which is 0 to some number, now it's going to be HR is in the range of all the values in this collection. So this collection holds HELLO. So the first time through, HR will be H. The second time through, HR will be E, so on and so forth. What I've lost track of, though, in this case, is where I am in the string. This gives me access to the contents of the string, but not necessarily that I'm currently at bucket 2 or currently at bucket 3. I could keep track of those things. I can say pos starts off at 0, and then I can say print at position and then I can say pos plus equals 1. So now I'm using an extra variable to keep track of where I am in the string if I want to. So this says that I have a H at position 0, an E at position 1, an L at position 2, so on and so forth. Now, why did I need to convert my pos to a string here? Go ahead. Yeah, so this guy's the concatenation operator. And if I want the concatenation operator to work, that's gluing things together. If I have a string on one side and I want it to concatenate, I have to have a string on the other side. Otherwise, it's going to be treated as the addition operator, and we don't know how to do math stuff with strings. All right, so this just allowed me to give myself a little thing like at position, and I glued the string 2 onto the end of it. Go ahead.
Is there a benefit of using one loop over the other?
Well, there isn't a generic benefit. The benefit would be if you need access to the particular element that you're working with, you need to know the position of it, then you probably want to use the numeric in range, so you have the value and then you just extract the position by using that index. If you know you're not going to need to know where you are in the string, you just want to investigate something with each character, maybe you're counting the number of vowels or something like that, then you don't necessarily care where you are in the string. You just care about the character and say, are you a vowel? If you're a vowel, I'll add 1 to some counter. If you're not, I won't. Something like that. So inherently, one's not better or worse than the other. It's really which tool do you use for the job that you're currently solving. Okay, so the trade-off for this version is you do not have access to the position unless you artificially give yourself access to the position. All right, so this allows us to go through a collection. And if you remember from before, we have a optional third parameter here to our range function. What's that third parameter do? Yeah, it defines how we step through that collection, or how, actually this for loop doesn't say anything about collections. It just says, how do I step through this range? All right. So if I make this a -1, it'll step through backwards. That makes sense? So it'll start at 0. It'll keep going as long as it is this, until it's not this number -1, stepping by -1. So this guy actually won't go through at all because we're actually starting our range in reverse. I'm starting at 0, then going to -1, then going to -2, then going to -3. I'm never getting up to this value. So I'd actually want to reverse these and say length of S minus 1, which is the last legal position in my string. And I want to go down to and including 0. So I'll go down to -1. This says go to -1, but not including -1. So it'll stop at 0. So same rules apply as before. I just have to consider that instead of the default counting up by 1, I'm now counting down by 1. And it does not go to this value. It's down to that value, non-inclusive. So it'll go from, in hello's case, 4 to 3 to 2 to 1 to 0 and stop. It won't get to the -1. If I set that as 0, I'll be missing the H. You'll never actually get to bucket 0. The last thing it'll print is the position 1, which is the E. All right, so now I'm going to make pause in string go through all the numbers. Keep in mind that this guy has nothing to do with the collection at this point. All this for loop does is it takes this variable on a voyage where each time through the loop, it'll start with this number, it'll end with this number non-inclusive, and each time it'll change by that much. And then how you use that number is up to you. If you want to just print the number out, great. If you want to use that number to get you a certain character from a string, that's fine too. Okay. For loops do not dictate how you use that number. They just say, here's a number, do what you want with it. All right, so I'll go ahead and print that number out as well, just so we see that number counting down. And actually I'll leave it in there, it's fine. All right, so here's my string hello. Here's me walking through it backwards. So we're seeing 4, 3, 2, 1. And there's the 0 where the H is. All right, that makes sense. So an important thing to consider here is when you're problem solving, this is a tool. Our for loop in this format takes this variable on a voyage between all of these numbers. It does not dictate how I use that number. That's up to me. In this case, I happen to use it 2 different ways. I used that number to give me a character from a string. I also just printed that number. So here's me getting the character from the string. Here's me just printing the number. That makes sense? Our brains dictate how we're going to use that value. All right, so questions about walking through strings or collections of characters. Okay. So strings are like this, and our kind of our go-to move for strings is length. We do have some other functions for strings that we'll introduce as we bump into them. There's plenty of them actually. But length is our, there's like an uppercase thing that converts the string to uppercase. There's one that converts it to lowercase, so on and so forth. All right, so now lists. These are collections of items in Python. So I might create a variable maybe called LST. That's going to be a bad one for this. So I'm going to create a variable called A. And this guy's going to be equal to, I'm going to put a little space in there so you can see it, the opening closing square bracket. That is the empty list. I could also create a list that already has stuff in it. H, E, L, L, O, for example. That is a collection of characters, that's the same thing that a string is, right? So if I come back in here and here, I'm just gonna, I'll copy this code. I'll go ahead and paste it on Slack and label it. We'll call this guy string intro. And then I'll go ahead and, well, I'm just going to change S. Well, we'll do it on S2. S2 is going to be H, E, L, L, O. So if I print out, notice if I say I print out the length of S2, that'll give me a 5. So that length function operates on collections, not just strings. And if I print out S2, let me get rid of this bottom one here. And for right now, I'll just get rid of that too. So we see that S2 has a length of 5, this guy here. If I print out S2, it prints out what S2 is, which is a list. If I print out S, it prints out what S is, which is a string. If I print S at bucket 0, and I print S2 at bucket 0, they'll both give me the H. So the way I index lists is the same way as I index strings. Make sense? All right, so we're starting to see that these, whenever I'm working with collections, I can kind of use the same tools. Okay, similarly, because that's a truth, I now know that I can, well, here, I'll leave that in there. I now know I can say for I in range 0 to length of S2, print out S2 at position I, and I'll get the contents of that list. Just like I was able to get the contents of a string. I just happened to create a list that was a collection of characters that happens to be the same characters that were in this string. I could certainly say S3 is equal to cat, dog, elephant. So that is a collection of strings in this case. So if I go through the length of S3 and I print out each element from S3, I now get the cat, dog, and elephant. See how that's working? All right, so lists allow me to move beyond just collections of characters, and they allow me to have collections of stuff. So here I have a collection of strings. I can have S4 being a collection of numbers, so on and so forth. When we get to objects, we can create collections of objects. Doesn't really matter. All right, that makes some sense. If I want to add stuff to a collection, I can say S4 dot append, everybody's favorite animal is the honey badger. Actually, I'm not doing S4, I'm doing S3 because that's my collection of strings. And now we see that when I go to print out that collection, I have one more element on it. So I initially created S3 to have 3 strings in it. Then I appended a 4th string. And now when I go through all the elements of S3, its length is now 4. So I print out all the strings that are in there. Make sense? All right, so that's how we can put things onto a list. I don't think for the next homework assignment we need to remove things yet. There's a pop function to remove things, but we'll burn that bridge when we get to it. Okay, so any questions about lists? All right, so I'll give you this as some sample code for your, come on. List intro code. All right, so now our what we were talking about the end of class last time. If I'm doing a binary number and I want to go directly to a hexadecimal number, well, we now have the skill through our two patterns where I can turn a binary number into decimal, then I can turn that decimal number into hexadecimal, right? I can accomplish this. But we want to think about what are the values possible in hex. Those are the values 0 through 9 and A through F, right? Generically speaking, this is 0 through 15. What is the value of 15 in binary? 15 is equal to 1, 1, 1, 1. 0 is equal to 0, 0, 0, 0. It actually could be written just as 0, but putting extra zeros on the front do not break it. But we see that the largest hexadecimal value is represented in 4 bits. That makes sense? So that means to represent all of the hextets, I need 4 bits. So 0, 0, 0, 0, 0, 0, 0, 1, blah, 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 all the way up to 15, which is 1, 1, 1, 1. So what I can do to convert a number from binary to hexadecimal, you write out the number. Now you need to make sure, remember, adding zeros to the beginning of a number does not break it. So I'm going to backspace here. So this is 1, 2, 3, 4. So this is a single hextet. 1, 0, 1. I'll go ahead and just put a 0 before that. That's my next hextet. This is the value 1, 2, 4. So this is 4 plus 1, which is 5. This is the value 1s, 2s, 4s, 8. So this is 12, 13, which is D. So this is the hexadecimal value 5D. I promise you, you will get the same result if you convert this to decimal and then that value to hexadecimal. We're able to take advantage of the fact that hexadecimal values can be represented in full in 4-bit groupings. 4 bits are also called nibbles. All right, so it's like a half byte. A half byte is called a nibble. Doesn't matter, but 4 bits let me fully represent the hexadecimal value system. All right, that makes sense? So binary to hex, just give yourself 4-bit groupings starting with the right, knowing that when you get to the far left, you might need to pad it, but it doesn't matter if I pad 1, 0, 1 with an extra 0 or not, that guy is equal to 5, right? Just make sure you start your groupings of 4 on the right, leaving yourself a maximum of 4 bits on the far left. Similarly, 1, If we look at this for octal, octal values are 0 to 7. A 7 is 111. You can represent it in 3 bits. 0 is 0, 0, 0. So now you take your number 1, 0, 1, 1, 1, 0, 1. You group it in 3-bit groupings. And this is the value 1. This is the value 3. This is the value 5. So this is 135 in octal. So you're able to go directly from binary to octal by recognizing that you can fully represent all of the octets, all of the values that make up the language of octal numbers in 3 bits, because the largest octet is a 7, which is all 1s. The smallest is a 0, which is all 0s. So I can just take my original number, starting at the right, group it in 3s, and that gives me, and then convert those little 3-bit binary numbers to their equivalent. So this is the octal version of this binary number. This is the octal version of this binary number, so on and so forth. And that's my 135. That makes sense how that shortcut works? Again, I promise you, if you convert this binary number to decimal and then convert that decimal number to octal, you'll get 135. So if you don't remember this trick, I encourage you to remember the trick. You can still solve this using just those 2 patterns we talked about last class. Just life isn't as easy. All right, questions, comments, concerns, bribes. All right, hopefully I see all of you at the Tech Talk tonight.